in for t? 10. What is 7 plus 10? There we go. That's p of 10. Now we're going to do p of 16. So is 16 greater than 1 and less than or equal to 10? No. So we don't use the first equation. Is 16 greater than 10 but less than or equal to 18? So which equation do I need to use? The middle one, right? So p of 16 equals what? 7. So to find p of 10 minus p of 16, we need to say what? 17 minus 7. What is 17 minus 7? 10. And what does that mean in context? How much more does it cost on the 10th than on, or not the 10th, on the 10th. How much more does it cost? $10. So that's what we'll say. It cost $10 more on the 10th versus the 16th. So when is it better to go get pizza? The 10th. Yep. Because the 6th, or is it better to go on the 10th or is it better to go on the 16th? You were right, Christina. 16th. Because which one's cheaper? 16th. Okay. Now, D. What is the significance of the domain restriction from 1 to 28? What is T in this question? What does it say T is in this question? So why is it important that they restricted the domain from 1 to 28? It's just the days in February, right? Because how many days are there in February? 28. Okay? If it would have done 1 to 30, would that have been accurate for February? No. Then the promotion would have ran to the 1st of March, right? So now we're going to look at E. We are going to take these equations and we are going to sketch the graph. So I'm going to write this right here. I wish y'all could, but unfortunately we can't. Okay, so for this graph, we're just going to sketch each of the pieces. But we have to make sure about one thing. What is the scale of this graph? What is it going up by each time? 2. Okay? So when we look at this, there is numbers technically in between there, right? All right. Just making sure. So for our equation, we have 7 plus t for the first part. What is our y-intercept for that? Seven. So at 7, we're going to put a point. Okay. Then what is our slope? Remember, that's what's in front of our variable. It's understood to be in front of our variable. 1. So our slope is 1 over 1. So it is going to go up 1. To go up 1, would I go to 8 or 9 or 10? What is up 1 from 7? 8. So we're going to go up 1 over 1. Up 1 over 1. And how long does it go up 1 over 1? Till it gets to what number? 10. And at 10, does it get an open or a closed circle? What does it get when it gets an or equal to part? Closed. Oops, I went too far. Okay, so we drew the first piece from 7 plus t from 1 to 10. Now we're going to do the second piece. It is 7 from 10 to 18, right? What type of line would that be? Would it be a diagonal line, a horizontal line, or a vertical line? Staying the same, so it's horizontal. So we're going to draw a horizontal line at 7 from 10 to 18. So I'm going to go to 7 and go from 10 to 18, draw a horizontal line. At 10, does that get a open or a closed circle? Open. At 18, is it an open or a closed circle? Okay, then we have our last piece. Our last piece is 18. That is also a horizontal line, right? So go up to 18. And I'm going to draw a horizontal line until it gets to what number? To 28. For that last one, open or closed at 18? Open. And at 28, it will be closed. So that right there is a graph of a piecewise function. So just like the equation, it is in pieces. Okay? So what we're going to do first is we're going to do some practice with evaluating piecewise functions. Okay? So we are going to flip to the next page, and we're going to look at question number 1. All right, for question number 1, okay, we have 2 equations in f of x. We have x plus 1, where x is less than -4, and we have x minus 5, where x is greater than -4, greater than or equal to -4. Okay, so we have our equation and the piece and like where it's at, the domain. So what we're going to do is we're going to look at each of these and we're going to figure out which equation we need to use, and we're going to evaluate it. So for the first one, we have -4. Is -4 less than -4? No. So we can't use the first equation. Is -4 greater than or equal to -4? Yes. So that is the equation we use. We're going to plug into the second equation. So we're going to do f of -4 is equal to x minus 5. What am I plugging in here? -4. What is -4 minus 5? It's -9. Okay. Now, we're going to look at the next one, which is -7. Is -7 less than -4? Yeah. So we're going to plug into that first equation. So we have f of -7 is equal to x plus 1. What is our x in this problem? What is -7 plus 1? It's -6. Okay. Now we're going to look at C. So C is f of 6. So is 6 less than -4? No. Is 6 greater than or equal to -4? So we're going to plug into the top or the bottom equation? The bottom. So f of 6 is equal to x minus 5. What are we plugging in for x? What is 6 minus 5? And that is how we evaluate piecewise functions. That's all we have to do, is we have to just identify the piece. Okay, from here, I want us to go ahead and I want us to look at number 4. Okay, number 4. So for number 4, we have our function f of x, and then we have 2 pieces. Our first piece is -2x minus 1 when x is less than -3. Our second piece is 4 minus x squared when x is greater than or equal to negative 3. So for our first piece, we have f of 0. Is 0 less than negative 3? No. Is 0 greater than or equal to negative 3? Yes. So we're going to use the second equation. So we're going to do f of 0 is equal to 4 minus x squared. But what is x in this problem? 0. What is 0 squared? What is 4 minus 0? 4. Okay. Now we're going to look at b. B, we are plugging in negative 1. Is negative 1 less than negative 3? Is negative 1 greater than or equal to negative 3? So we're going to plug in there. So we have f of negative 1 is equal to 4 minus x squared. But what is x? It's not 1. Okay. So we have 4 minus negative 1 squared is positive 1. So it's 4 minus 1, which is? Okay. For this one, I want you to cross that out. We are going to do 4 of negative 4. Yeah, I had a typo there because I wanted us to do different types. Okay, now, for 4 of negative 4, is negative 4 less than negative 3? Yes. Okay, so we're going to plug into that first equation. So f of negative 4 is equal to negative 2x minus 1. But what are we plugging in for x? Negative 4. What is negative 2 times negative 4? A negative and a negative make a. So we have 8 minus 1, which is? And then we're going to look at question 5. So 1 and 4 both have 2 equations. Or they are in 2 pieces. The equations are in 2 pieces. Whereas number 5 is in how many pieces? 3. Okay, we still do the exact same thing. Okay, so our first piece is, it is 1 when x is less than negative 3, less than or equal to negative 3. It is negative x plus 5 when x is greater than negative 3, but less than or equal to 2. And it is 0 when x is greater than 2. So that is our pieces. So first, we are going to plug in negative 3. Is negative 3 less than or equal to negative 3? Yes, less than or equal to negative 3. Okay, so we're going to use that first equation. So f of negative 3 equals what? 1. Do I need to do anything else? No, that's just the answer. Okay. Now we have negative 4. Is negative 4 less than or equal to negative 3?
No. Wait, yes.
It is less than. So we're going to do f of negative 4 is equal to 1. Oh, they're not all equal to 1. Okay, for this one, we have f of 2. Is 2 less than or equal to negative 3? Is 2 greater than negative 3 and less than or equal to 2?
Yes.
Yeah, because it's equal to 2, right?
Oh, I thought it said negative 2.
So now, we're going to plug that in. We have f of 2 is equal to negative x plus 5. What are we plugging in for x? 2.
I thought less than. I thought it was when it was greater and negative.
So it's less than or equal to 2. It just depends on whatever the symbol is. If it has the line under it, it means or equal to. So it can be either way.
Oh, okay.
Okay, so what is, so we have negative 2 plus 5, which is 3. Okay, our last question, we have 8. Is 8 less than or equal to negative 3? Nope. Is 8 greater than negative 3 and less than or equal to 2? Is 8 greater than 2? So what does that mean f of 8 is? Okay, so I want y'all to go do number 2 for me real quick. Go do number 2. You have 2 pieces.
There's the line under.
Correct.
I think I'm doing this.
All right. For f of negative 1, which equation do I need to plug into, the first or second? First. So it equals? Negative 1. For f of 3, do we plug into the first or second equation? So what does it equal? 4. For the third, we have f of negative 5. What do I plug that into, the first or second? The first. So it equals? Negative 1. Okay. And we are going to look at... No, we are doing number 3. Okay. So for number 3, I want us to look at C together, just so we can look at it. Okay. So we have 2 equations. We have 7x minus 5 when x is less than negative 2. And we have negative 1/2 x plus 2 when x is greater than negative 2. We're going to do C together. So is 6 less than negative 2? No. Is 6 greater than or equal to negative 2? So we're going to plug in to the bottom equation. So we have negative 1/2 x plus 2. What are we plugging in for x? So here, we have a positive and a negative. What does that make? And what's half of 6? Then we have plus 2. What is negative 3 plus 2? Negative 1. You are going to do that same thing and plug into A and B. Which equation do we plug both 0 and negative 2 into? The second one, right? So if we start by plugging in 0, we get negative 1/2 times 0 plus 2. So what does that equal? 2. Okay, if we plug into B, we have negative 1/2 times negative 2 plus 2.
Negative 1 and then.
What is negative? So a negative and a negative make a positive, or a negative and a negative make a positive. So what is half of 2? What is 1 plus 2? 3. So you should have 2 and 3. So that is how you evaluate piecewise functions. Okay? So when we evaluate, all you do is you figure out which piece it goes into and then plug it in. That's all we got to do. So now I want us to go ahead and we're going to graph some piecewise defined functions. What we need for this is you need to be able to draw a straight line. So if you need a ruler, grab a ruler. And you need a pencil and an eraser. If your pencil does not have an eraser, I have a bunch of cap erasers over there in the glue sticks drawer. Unless you just want to.
No, I think you should.
You need a pencil and an eraser and a straight edge if you need it.
Breaking.
Just a little.
It's okay, she doesn't care. Look at mine. Oh, I think it's an elephant. Oh. I don't know.
It is an elephant. Yeah, that's the trunk of the elephant.
It's a scary elephant.
I also have giraffes and llamas.
I don't think this one.
All right. So we are going to look at question 6. Okay. So we are going to graph piecewise functions. So we're going to graph the pieces. So we're going to start with 7x plus 3, or 7x minus 3 when x is less than 0. So we're just going to graph that line. Okay, so with your pencil, what is our y-intercept of 7x minus 3? Negative 3. Let's put that point. What is our slope? 7 over 1. So we need to go up 7. 1, 2, 3, 4, 5, 6, 7 over 1. Up 7 over 1. I'm even going to put a point going the other way just to get me a good line. And then I'm going to draw in my line. That was a very crooked line, so I'm going to fix that line. Okay. Now, we have x is less than 0. So if I'm saying x is less than 0, is that talking about the part of the graph that is to the left of 0, or is that about the part of the graph that is to the right of 0? Which one is less than 0? The left. So what I'm going to do is I'm going to take my eraser and I'm going to erase everything to the right of 0. Because when is this line only there? When x is less than 0. Okay? So we are taking only the piece that's less than 0. And it's 0. Okay? We are using less than. Remember, when it is less than, you use open circles. When it is less than equal to, you use closed circles. Okay?
Is it like a...
So will it be an open or a closed circle?
Can you put the little arrow on it?
And we will put the little arrow on the other end. Okay, now, we are going to look at the second equation. So for the second equation, we have negative 1/2 x plus 5 when x is greater than or equal to 0. So to graph that line, where is our y-intercept? What is our slope? Down 1, right 2. Down 1, right 2. So I'm even going to put a point going the other way just to be good for my line. Okay, so we draw our line. This has to be when x is greater than or equal to 0. So is that talking about to the left of 0 or to the right of 0? When x is greater than? To the right. So we're going to erase everything to the left. Will it be an open or closed circle? Okay, the better you get at it, the less you'll have to draw before you erase. Okay, it is safer to draw the line and erase what you don't need than to try to graph it without plotting everything. Okay, so this is our piecewise function. Okay, we're also going to go ahead and we're going to graph number 7. Okay, so number 7 also has 2 pieces. We're going to start with the first piece. which is 3/2 x plus 3 when x is less than -2. So to graph that line, what is our y-intercept? 3. What is the slope? Up 3 to the right 2. I'm also going to put a point going the other way just to make my graph better. Draw our line. So this one tells us that it is when x is less than -2. So here is x is -2. Which side do I need to erase? Do I need to erase the left or do I need to erase the right? We're going to erase the right. And will I put an open or closed circle for that one? Open.
If you have multiple points, would it all be open?
We're going to talk about it. Okay. Now, we have to look at the second equation. So we have 4x plus 8 when x is greater than or equal to -2. What is our y-intercept for that one? 8. What is our slope? Up 4 to the right 1. I'm even going to put some going the other way. Down 4, up 1. Draw my line. Okay. Do I need to erase, this is x is greater than or equal to -2. Do I need to erase the right or do I need to erase the left? We're going to erase the left. Okay, well at -2, does that get an open or a closed circle? Closed. That closed circle is in the exact same place the previous open circle was. So we're good. That is okay. That's fine. Okay, whenever I have one of those, I try to just show that, but it's hard to show that, okay? So when we have a piecewise function, we have a couple different things that can happen, okay? So we can have a piecewise function like number 6, where our graphs jump from one place to the other. When it has that jump, it's discontinuous. You have to pick up your pencil to draw it. That's fine, okay? A piecewise function can look like that. A piecewise function can also have where both pieces connect to make one line. It's got a corner somewhere. Okay? When that happens, it's continuous though. So it can either be a continuous line or a discontinuous line. And so either way works whenever we're dealing with piecewise functions. Okay? Both are good. We're just graphing lines for specific areas. Okay? And the reason it's easier to graph, once you get a little bit better at it, we can start saying, oh, okay, well, the y-intercept for this one here. The y-intercept is at 8, and it's going to be greater than -2. I'm just going to draw the points going this way and connect it down to -2. You don't have to draw everything once you get better at it. When I draw them, when I'm making answer keys and stuff, I don't draw the whole line and erase it. But as we're getting better at it and learning, it is so much better to just draw the line, erase the pieces you don't need. That's one way that you're going to guarantee you don't mess it up. Okay? So, yeah, that's piecewise functions. How do we feel about them so far? Okay, so let's split it. How do we feel about evaluating piecewise functions?
Which one's that one?
That's where we just plug in the numbers. That one, I like it. How do we feel about graphing piecewise functions? We're getting a little bit better. Well, we're going to do 4 more together tomorrow, and then we're going to do some independent practice on it too. Okay?